We are going to continue with the next speaker, which I'm looking for, Philipp Krenn. Is Philipp Krenn in the room?
Yes.
Hi.
Hi. Finally.
Yeah. And I have to tell you that we are very late on schedule. And that is my fault. It's my fault because I'm not cutting people while they're speaking, so I find that very rude. But at the same time, we have to be on schedule. I don't know how to do that. It's a dilemma. So, Philipp, you are going to talk to us about MongoDB, MySQL, Jenkins, AWS, NoSQL, cloud computing trainings. What are you going to talk to us about? First of all, where are you coming from?
I'm from Vienna, but today we will mainly talk about security.
All right.
In the cloud. So I guess we can get started, right?
Perils of the cloud. That's great. Thank you.
Yeah. Okay. Hi, everyone. Yeah, I know it's hard. Try to stay with me. As I just said, I'm Philipp. I'm from Vienna. And I hope my clicker works. Clicker. Yeah. Okay, yeah. Finally. Yeah, Vienna, city of fatty foods, classical buildings. No, classical buildings. And beautiful women. Come on. It's too far. Yeah, I'm happy to change it. If it would be working. Yes, thank you. Beautiful women. Thank you, Conchita. Okay, what do? I work for a small company. We have everything in the cloud. We do electronic data interchange, which is exchanging business documents in the cloud. So we are doing orders, invoices, and stuff like that. So if we screw up, bad things happen. For example, we run out of beer. So the supermarkets try to order their beer through us, and if we lose the order, there won't be any beer tomorrow. So that's one of the reasons why security is very important for us. So if somebody shuts us down, no beer. So that's basically the why. Now let's take a look at some examples. Maybe you know them. So this is code spaces, or basically this was code spaces. They were kind of a hoster for code, like GitHub a bit, and somebody got their keys on Amazon and took down everything. And what you've just seen, that was the last post, so they just went out of business after that. Or DrawQuest, which was kind of a famous game engine, and many people played it. Somebody got their keys and started mining Bitcoins. And they just shut it down because they didn't have the resources to clean up. And it totally makes sense. So you use $10,000 on Amazon to get out, I don't know, $500 of Bitcoins or so. So it's kind of a real waste of money. Or Bonsai. They provide Elasticsearch hosting. So they provide the search tool for you. And somebody shut down all their instances in the morning. And when they woke up to their beepers, all of their instances had been terminated and everything was down. So this is why you should take care about it. And yeah, somebody compromised their key and everything was gone. So I know how you're feeling. Yeah, both of the general temperature and because of this. So in general, who is using Amazon already? Okay, very few. Who is using cloud services in general? Okay. Who is thinking about using cloud services? Did you think about security? So I will try to consolate you. So what can we do about it, and how can we secure our infrastructure? So I've put together a little how to secure your Amazon account in 1,100 easy steps. So let's keep going, because I only got half an hour left. Starting at 0, lock away your root account. So if you're on Amazon, you get your root account in the beginning, but you should never use that, because that's absolutely without any limitations. If anybody ever gets the credentials for that account, you're doomed, because they can do anything. Point 2, always use identity and access management, IAM. And because IAM is kind of a strange acronym, I've got like a little memory bridge for you, how you can remember the IAM, because IAM is really what you are, but there's somebody who can tell you better. Okay, I'm sorry. Right, so IAM is what I am, especially on Amazon. So create one of these IAM users for every user you use or every service you use, because there you can specify the credentials and what they're allowed to do. Don't use the root account, create a dedicated account for that. Use groups. Don't just throw the permissions onto the users, but use proper groups. So you can set up groups, and all the groups are allowed to do something. And while you cannot nest the groups, one IAM account can belong to multiple groups. So that's kind of the way you could do the nesting. So you can create pretty powerful and well-structured setups with that. 100. We're progressing nicely. Only allow what is absolutely necessary, like the principle of the least access. That's absolutely valid here as well. So for example, here we have a rule. It's, JSON is all the rage, so it needs to be JSON. What we have defined here is on S3, so the file storage on Amazon, you're allowed to list all the buckets, so the containers containing the files. You are allowed to list all of them, so star is list all. And for common example backups, anything that's in there, you can store objects, you can retrieve the objects, and you can delete the objects. And you can define that for every bucket or globally, so you can really put those permissions in a fine-grained fashion. You can do that both for instances, for any kind of database, for storage, anything. You just need to set it up properly. As always, use strong passwords. Either, XKCD tells you how to use proper passwords, or probably even better, use a password manager, just generate the long random string and have it inserted for you, and you're all set. One biggie is use multi-factor authentication. So multi-factor authentication always requires at least two things, or sometimes it's called two-factor authentication, depending on it. So you have the password, that's the knowledge you have, and then mostly it's just owning something. That's the second thing you need to have. Commonly a phone or like a YubiKey or whatever. But phones work great. Amazon supports the Google Authenticator app. You just have your keys in there, and you need both your credentials and the key, which is only valid for a minute, to be able to log in. So if you want to log in, you have to provide your account, your username, your password, just as before. But in addition, you need to check the MFA token, and then you need to enter your token. And only with that information, you can actually log in. Oh, yeah. But what happens if your phone breaks? Because we've had that. So if you're just a regular IAM user, that's not a big problem, because then you have other users who probably have the same permissions, and they can just reset your account. So that's no big deal. But what happens if your device for your root account is broken? Because nobody else can reset the root account. So there are security questions. We put in random values because we thought we were very clever, so nobody could circumvent our security with the security questions. But we didn't store the values of the security questions. And it is really hard to regain access to that then, because Amazon is pretty strict about that. We tried personal contacts, whatever we had, but they require you to have a signed notary form, and they require that in English, and Austrian notaries will only sign German notary forms, and it's kind of a real battle, and it takes a lot of time, it takes a lot of money. Don't do it. So yes, use a second token for your root account, but at least store the security questions somewhere so you can reset it if everything else fails. So broken phones can be tricky. Never commit your credentials. So the classical case is you have some internal tool, you just commit your credentials because nobody will ever be able to see your code. And then at some point later on you decide, oh, that's nice, we could open source that, that's a nice little library. And yeah, before you know it, somebody takes over your whole account because of that. One other thing we are religiously doing is IP restrictions. So to access, so my own token is only valid from our office, and from the VPN we can connect to the office. But no other IPs are allowed to use my token just because of security. So even if I gave you my token, you couldn't do anything with it without my RIP address, because it totally makes sense. Somebody from Russia, China, wherever, shouldn't be able to access our account and just do stuff. One thing that might be, oh yeah, that's how you can actually set it up. So that's how my token would be set up. So I have basically allow every action on every resource, so do everything, but with the limitations, just these two IP addresses. Okay, there's not actually ours, but with this, like, this is our office and this is our VPN gateway. Only from these two IP addresses or ranges, you would be able to access anything. And the tricky thing is, at first you think it isn't working as expected because you can still log in from another IP address. But if you watch closely, you can actually see that on everything you see here, there is a, you're not authorized to do whatever. So even when you can log in from a different IP, but you cannot do anything. So it's working as expected, but at first you might think, maybe it's not working. But actually it is. One nice thing is enable billing alerts. So on your Amazon account, you can just say, send me an email. Unfortunately, you have to set specific amounts, so you cannot say, send me an email every $100 or so, but you need to say, send me an email when I reach $500, $1,000, $1,500, whatever. This is especially useful because the criminals who are mining Bitcoins are not stupid. They will normally get your credentials and then wait for the beginning of the next month, so you have a full month to exploit your account until you see the final bill and see what has been happening. So create those billing alerts, so you get these emails and we know, okay, we get the $1,000 alert in the middle of the month, and pretty close to the end of the month we get the $2,000 alert, and if it's much earlier, we now either we have configured something badly and started too many instances or something like that, or someone has broken into our account and yeah, did whatever. That's what such an email look like. It's just an email, and will tell you at this point in time you've reached that amount of dollars, and the estimate for the whole month is like whatever. If you have been compromised, CloudTrail is really useful. It is basically just a log of your keys and what actions they have done. So if you have been hacked, it's at first often unclear how did this actually happen. But if you have enabled CloudTrail, you have actually the log files on Amazon S3, and you can look through them and see what has been happening. So this would be such an event. And here you can see our user, Alice, with some example key, has at the 9th of May of this year stopped the instance with this IP and this ID. So you can really see who has done what at what point in time. And then you know, okay, somebody has stolen Alice's key. We need to reset Alice's account, but all the others are probably good. So you can really then actually see what has been going on and not just see, okay, everything has been terminated, no idea what has been going on. So this can really make cleanup much easier. Check your security status. Amazon provides these statuses so you can see, do you have MFA enabled? Do you have IAM users? All these checks. If they're not all green, change them. They should be. It's pretty easy. One thing for us that was the best Amazon investment ever, premium support, because if you don't have premium support, you have these public forums where you can write the problem and then somebody might answer or maybe nobody is answering. And with premium support, you have actual Amazon employees who will answer your support calls. It costs 10% of your monthly bill for the smallest account, and if you want, I don't know, whatever platinum premium support, it will cost you more. But otherwise, it's just plus 10% of your regular bill, and they will be able to help you. And with this premium support, you also get these nice little dashboards, and there you have stuff like security. 5 checks are green, 4 are yellow, and 2 are red. though the to red might be a little misleading because it's just, okay, you have like you have an IP range, or you don't have any IP restrictions on a certain port. But for example, port 80 and 443 for HTTP or HTTPS, I want to limit that. I don't want to limit that. That's fine if it's publicly open. So that might be a little misleading, but it's still good to check that once in a while and see how many red points do I have, how many are yellow, what do I need to change. And this will also send you weekly emails to tell you, okay, this went from green to red. And if this is unexpected, you should check it. So now that we know what we need to do, how can we actually implement it? So one of the very important rules is, if your key has been compromised, rotate it. Even if it has just been on GitHub for a minute or so, somebody might have stolen it in between, and people are actually scanning GitHub for your tokens. And Amazon themselves are now scanning public GitHub repositories for Amazon tokens, because they know the bad guys are watching for these tokens and try to fetch them. So it's just a game of who is faster to get the key first. Either Amazon will warn you, or the bad guys will get your key and then start whatever they want to do. So once it has been published, just rotate the key. Now, the one thing that has always been a question for us is where do we actually keep our secrets? Because if you have like many applications and you want to deploy them to like 20 or 30 applications and servers, how do you keep all the credentials in sync, and where do you keep them? So for us, there were two options basically. You either keep it in environment variables on the instance, but that's a bit of a pain to keep in sync. Or just have an encrypted file with all the credentials in GitHub, whatever, and you just decrypt it once you deploy the actual application. So that's what we are using. So it might look something like this. Yeah. So actually, where did we get the idea from? Some guy called eJohn. Do you know who eJohn is? Have you ever heard of eJohn? He wrote a very nice blog post, and he wrote some little JavaScript framework nobody is probably using. So that's John Riesig is eJohn, and that's his pretty nice blog post, and he describes how he's doing it, and we basically copied it at first. So what he's doing is you simply have a shell script where you throw in your credentials or your certificates or whatever, and then if it doesn't have the file extension AES-256, it will just encrypt the file with OpenSSL, and if it already has the extension AES-256, it will decrypt the file. And that's all there is. And we have git ignore rules, so we can only push the AES-256 files, but not the actual password files to GitHub. And that way we can safely push all the securities-related stuff to GitHub and don't need to worry about it. And once we deploy our applications, we just decrypt it on the instances and we're good to go. And then all the attributes or passwords are kept in sync. And we don't need to worry about it. And of course, the development or testing attributes we keep in plain text because they're not of much value anyway. Yeah, so if you have an encrypted, for example, trust store, we simply do the encryption. We overthrow the warning, okay, if you don't have the password and you should have it, this is the email address, enter the password, and in the end you have the decrypted file, and that's just it. So it's very easy to get going. But you could also use more fancy approaches like the vaults from Ansible, the Chef or Puppet-like tool, or HashiCorp now has a very recent product where they have a nice solution where they call it Vault. It's available over the network. They provide audit, so you can see what credentials have been accessed at what point in time. You can revoke credentials and stuff like that. So HashiCorp always provides fancy solutions which might be of interest. So our workflow then is very simple. Everything is a file, probably encrypted. So we push our code to GitHub. Then it gets automatically built on Jenkins in our example, but we don't really mind. Since it's Java, we then have a jar file, which we throw on Amazon S3, the file storage. And from there, it just gets deployed to all the instances. And on the instances, only on the instances, the stuff gets decrypted. And if you're on the development server, only the development properties will be decrypted. On the production server, only the production properties will be decrypted. And we have different passwords, so some people only have the development access, and others also have the production access to decrypt it, so we can nicely separate that. Final word on trust. So there are some entities we just need to trust. For example, Amazon, they run our stuff, we need to trust them. The password or the credentials need to be on their servers in some form. Also, the build servers, they only get the stuff in an encrypted fashion, but they still need to get the files. And of course, GitHub we need to trust as well. But who we don't trust is all these little add-ons you have, like so the tools into GitHub. And many tools will just want some kind of access to your GitHub account, and we're very careful for that. And on GitHub, you can actually say you need to allow or you need to whitelist applications so they can access your code. And we're always trying to limit that to an absolute minimum. For example, at some point, we wanted to use the software called Whoboard, which just provides some kind of better project management on GitHub projects. But they would have needed full access to our code, and we said, okay, that's just, I don't know, 3 people. They have no dedicated security staff, unlike Amazon and GitHub. I don't think they know what they're doing. Probably they are not doing it that well, so we simply cannot use that service, unfortunately. Some other guys at our company would have loved to do that, but we said, yeah, sorry, it's simply not worth the risk. So to conclude, this is one final example of just of the end of last year. Somebody had a small project, and suddenly on Amazon he had 140 servers running. He only had his S3 key, and he had just pushed it to GitHub and noticed, I've done a bad push. And then he rewrote his history and did a force push to overwrite everything. But still, within 5 minutes, his GitHub, his Amazon credentials were stolen, because the bad guys are not stupid. They will actually monitor public GitHub repositories, and on every commit, they will check the diff. And if you have just pushed it once, they got it. So all the things you could do wrong probably went wrong here. For example, so if your key has been compromised, don't try to be fancy. Don't try to revert it on GitHub. Just rotate the key. If you just need access to S3, only give your key access to S3. Don't give it global access. And in general, don't ever push your credentials to GitHub. Just try to stick to the basics, and you're probably good. OK. That's it. Any questions? No questions. Yes? Sorry, I cannot understand. Yes, please take the microphone.
So I didn't quite get the fact. So you said that you're encrypting your credentials, and where do you store your passwords for the encrypted files to decrypt them?
Right. So for our business, we've decided continuous delivery is currently not what we are doing. We are currently we have our builds, and once we're satisfied, we are actually promoting the build. So the pushing it to S3, the final build, is just a manual step. And then somebody needs to go to Ansible and say, OK, push that application out to all our servers. And in that phase, we interactively ask for the key. So you could put the key somewhere else, but we always said, yeah, it's kind of a risk, because if everything is automated, you need to put out your keys somewhere. But we said, OK, for our business, as I said in the beginning, it's kind of stability is the most important thing. So it's not about fancy tools or stuff. It just, you need to get these orders out and then get the invoice back. It's not really about features, but stability. All the stuff really needs to be we need to keep it working. So that's we don't need to do the whole fancy continuous delivery stuff, but we can actually do custom deployment. So yeah, it's just a shell script. You call it from your local machine. It's just done in a few seconds. And you need to enter the key, and then that's off. Right. And also because only some people have the production keys, only they can actually do put stuff into production. So we can also limit that on that basis and have some kind of security blanket there as well. Any more questions? Yes.
Hi. Okay, it's working. I come a little bit later. I'm just wondering myself, so you are downloading the file from the repository, and then you are deploying the application, right? So I'm just wondering, there will not be a security issue or something like that because the password is going to go in plain text, right, or not?
You mean on the instance?
Once you decrypt the password, right, and you
yes,
deploy your application.
Yes. So once it's on the instance, it needs to be in plain text. The problem is, however you try to structure it, some credentials you need to have either, of course, you can keep it just in memory, but the problem is, what happens if the instance just restarts, which might happen on Amazon. So we just have it on the file system, just so we can survive restarts. But in general, the instance needs, for example, to access the database, you just need the password. There's just no way around it. You need the password to access our production database in some form. Your application needs it in one way or the other. So yes, we have it as a file on the file system, but you could keep it in memory, but otherwise you need to have it in some form on your instance.
Yeah, but maybe I didn't make myself clear. The password once is being once you get the file and you are decrypting the file and we are getting the password, right? Then you're going to deploy the application, right?
Oh,
and
no.
Once the application is being deployed, password is being clear or not? This is not.
No. So we take the zipped and encrypted stuff
okay.
from S3 and transfer that, but that's also HTTPS, so that's also secured in some form. But the actual decryption only happens on the instance, on the final instance. So really the decryption is just on the instance and just exactly for the password it needs. So the development infrastructure...
I got it. Yeah.
Okay. So the development infrastructure only gets the development passwords and not the production ones. So that's as separated as it can be.
Thank you.
You're welcome. Any more questions? Yes.
In multi-server deploys, are you actually inputting the password multiple times for each server?
No. Ansible will handle that. So with Ansible, we just have, just to be sure, we do a serial. So it just goes to the first instance and does everything there, and then to the second. But Ansible will handle that. So we don't, if we deploy to 4 servers, we don't have to enter it 4 times, but just 1 time. But yeah, since we're in the luxury position, so we just have paid traffic. So for every message our customers send us, we get money. So we don't have that many servers. Like, I don't know, our applications run like 2 or 3 times just to stay up. But load is not the major problem, because once people start paying you like 50 cents or so per message, they will actually think what they're doing. So the load is, for us at least, not the example. But you can definitely structure in a way that you only need to or paste the password a single time, and then it will be kept in memory from wherever you deploy, and then it's good to go, yeah. All happy? Okay, great, thanks.